Okay, so let's start with those tangents and approximations. Yeah. Oh, this is just a list of all the things we're going to go through. I will try and take a picture and put the timestamps for each of these. So this is the start, and this is where we're starting. And then I will put those in the description, so if you want to skip to anything. Okay. So when we have a tangent line, we need two things. We need a slope and we need a point, right? So oftentimes they're going to say, hey, you have some function f of x. And let's just say we're looking at f of x of 1 over x squared. We want to find a tangent line at x equals 4. And we want to use that to approximate f of 4.1. So what we're going to do is the first thing we need to do is we need to find our point and our slope. So to find our point, all we're doing is we're taking that 4 and we're plugging it into our equation. So we're going to say, okay, f of 4 is equal to 1 over 4 squared. Which gives us what? 1 over 16. So now that I have a point, I also need my slope. But my slope comes from f prime of 4. Which means I first need to find f prime of x. So take a second, we have that 1 over x squared for f of x. You need to rewrite it and then use power rule to find your f prime of x. Alright, so what do I rewrite this as? So x to the negative 2?
Oh.
That's what our rule says? Yeah. So then f prime of x, my power is going to go down into the front. And it's going to be a negative 2x to the what? Negative 3. Be really careful. A lot of times little mistakes on quizzes will be things like negative 2 minus 1 is equal to 1 or negative 1, neither of which are correct. We want to make sure we're keeping, since it's the same sign, negative 2 minus 1 gets us that negative 3. Make sure you sign in before you leave. Okay. So once we're here, f prime of 4, all we're doing is plugging 4 in. So we're going to have that negative 2 divided by a 4 cubed this time. Do we know 4 cubed?
Yes. 56.
Hmm?
56.
Should be 56 with the 2 on top. So if I have two even numbers, I can simplify this fraction. Negative 1 over what?
Oh. Negative 1 over 23.
No, 23.
No.
28. When we have an odd number here, we need to say what adds to 16 for our first, or our ones digit, rather than what adds to 6.
You divided it by 2?
Yeah, I divided each by 2 here.
Did you get the negative 2x to the negative 3 by doing that x? Yeah.
Our power rule. So I took my exponent, I brought it down into the front, and then I reduced it by 1.
No, I mean, how did you get it to the bottom? Negative 2 over 4 cubed. Did you just do it?
Oh yeah, I did the inverse of our rule here, because this is the same as that 2 over x cubed. Yeah. Okay, we have a point, we have a slope. We're going to put that in point slope form. Okay. M times x minus x1 plus y1. So take a second, write your equation. Remember, we're going to replace y with what? What's the notation we want to use? So this is just our y variable. L of x. We want it in function notation, especially if they ever ask us for an approximation. Yep, whenever we find that tangent line, if they also ask for an approximation, we want to make sure we switch it over to function notation.
And even when they're just asking for the equation?
If they're asking for the equation, it's fine for either. This just helps us use better notation for when we do our approximation. Alright, so L of x, what is my slope? Negative 1 over 28. What is my x1? 4. And do not forget your plus y1. What's y1?
1 over 16.
The 1 over 16. So now to approximate, we would say, okay, well, f of 4.1 is approximately L of 4.1. The reason our notation falls apart here if I leave it as y is because it's weird to say f of 4.1 is approximately y. Because y could be any value without a specified x. Function notation specifies the x value that we're looking at. Now I can use equal signs, so all we're doing is plugging 4.1 in. Negative 1 over 28. What's a 4.1 minus 4? 0.1 plus 1 over 16. If this were a free response, what should we do?
Box it.
Stop. You're done. You can box it if you want, but it's recommended that you don't box your answers.
Oh, really?
Is it because that would be your final answer? They'll take off?
Yep, so say you made a silly mistake here in subtracting the 4 and 4.1, but you had written the equation up here with 4 minus 4.1. We could take that one as your final answer.
But you still get deducted points for it, right?
Depends on how it's formatted as well. So they give very specific follow-through points. So it's pretty clear when, like, you'll see the rubric once we go through the free response together after this quiz, because hopefully we'll be able to get those back to you on time this time, since Common Assessment will be broken. Or Common Assessment app, not like the, yeah, the app, the Common Assessment app. Yeah. Okay. Any questions on this? Okay. So we're gonna practice one.
By ourselves.
Okay, by yourselves. Well, you can talk to each other, but does anybody have a favorite function?
X squared. That's my favorite one.
X
We just do
squared?
X squared.
1 over x.
We'll do x squared. So, at x equals, pick a number between -5 and 5.
5.
3.
6.
5 was said first. That's not even in, that's not. So, and we're going to use that to approximate f of 4.9. So, if you're watching this, pause this, try it. So I'll give you guys, like, we should have found that f prime of x was 2x. So our slope always comes from our derivative, so we should have been looking at f prime of what we're looking at 5 for our slope. So this one gives us our slope, because our derivative equals slope. I'll use my original equation for my point though. So f of 5 to find that point, which should be 25. So I saw pretty much everyone saying, okay, L of x here is going to be equal to a, what was it, 10, x minus 5 plus 25. So that was really good. I did see a couple people just saying y. Be careful, we want to be really specific and use a function notation so we can connect it to an x value. That way when we do our approximation, they know what we're looking at. So then we would say that f of 4.9 is approximately L of 4.9. This is very particular thing that they'll be looking for when you do any approximations. Then that equals that 10 times, you can either put 4.9 minus 5, or you can say, hey, I know that's negative 0.1. Either is fine. Plus 25, and you can stop here. For your response, boom, we're done. It should simplify out fairly easily though, because it's a 10 times a 0.1. So a negative 1 plus 25, which gets us to 24. But either way is fine for you to stop it.
So you first plug in the x they give you and then you do that.
Yeah. You can always just sit up here too. It's an option. Oh, it's fine.
You want to go to our newspapers?
Okay. Any other questions on tangent lines? Alright. So, we're going to move on to continuity at a point. Okay. Continuity. So, continuity at a point has to do with proving that something is continuous, or making something continuous. So oftentimes if you're going to be proving continuity at a point, what they're going to make you do is they're going to say, okay, I'm giving you some function on an interval, prove that it's continuous, and they'll typically give you some piecewise function. Like in x squared when x is greater than 0, but let's say they gave you a 1, I don't know if I want to do this, but 1 over x minus 2 when x is less than 0. So it's either say, hey, prove that this is continuous or discontinuous. So there's 3 things we have to do to prove continuity. Oh, sorry, or equal to. Or equal to on that one. We need to do 3 things. We need to show that f at that number exists. So f of a exists. In this case, a would be what? 0, because that's where we're worried about it. 2, we need to show what? That's what we're trying to do overall.
At the left and right?
So we need to show that the limit exists, which we do by looking at what? Yeah, we look at the limit from the left and make sure it's equal to the limit from the right. And last thing, what do I need to show? Thinking IVT.
Oh, that's continuous.
Therefore,
No. We need to show that they are all equal to each other. Our Big Mama equation. Big Mama equation. Do you remember that conversation?
Big Mama?
Big Mama?
Oh, yeah, because I said they come on. Yeah.
Yeah. So we need to show that all 3 are equal. So in this example, what do you think is going to be, which one of these do you think is going to break?
the third one.
Technically, but the second one is the first thing we're going to see. Because this limit, what happens when I plug in 0 here?
It's going to be undefined. Oh,
Here.
Oh, here? It's going to be 0.
0, but what's 1 over 0 minus 2?
Negative 2.
Negative 1/2.
I meant at the bottom.
And are those equal?
No.
So does my limit exist?
No.
No, and so that's what we would do to justify this. So they're always going to ask for justification. So what we would have to do for this problem is we'd show step 1, we'd say, well, what is f of 0? Well, when it's going to be equal to 0, I use my top equation here. Well, 0 squared is just equal to 0. And then I'm going to say, okay, I'm going to try and show that this limit exists. Well, the limit, as x approaches 0 from the left of f of x, I can do direct substitution for both of these. So I'm going to say, okay, here, in this case, on the left is approaching from negative, so I'm going to be looking at my bottom equation, negative 1/2, and my limit as x approaches 0 from the right of f of x. That number is larger, so that's my top equation, 0. But these are not equal. So to justify, we don't even need to go to this third step. We would just say, okay, at x equals 0, f of x is not continuous. And we say because the limit as x approaches 0 from the left of f of x does not equal the limit as x approaches 0 from the right of f of x. It is more likely when they do this, though, that they'll give you something that you can prove is continuous. So you need to go through all 3 steps for those ones.
What about when it's like x is not equal to like, how long would that be?
Okay, so we're gonna try one. This is gonna be the most janky video. Where it says, okay, f of x is equal to the set of equations where we have x plus 2 divided by x squared minus 4. And this is for when x does not equal 2. And then they're going to say something like, oh, 2k plus 3 is our equation for when x equals 2. And they're going to say, hey, what value of k will make f of x continuous? So what you're going to do is you're going to use those 3 steps that we have to do to show continuity in order to try to evaluate k. So I'm going to give you guys like 3 minutes to do this. If you're watching the video, just pause, attempt it, and then... Oh, crap. Alright, quick typo, that should be a -2, so hopefully you waited to pause long enough to see that. Red. So, we need to go through our 3 steps still. First thing is just saying, hey, f of a exists. So, our a value we need to look at in this case is going to be that -2. Sorry, negative should be there too. So we're going to say, okay, well, what is f of -2? Well, I'm just plugging it into this value here, but are there any x values? No, so it just equals 2k plus 3. If there were x values, we would just plug in that -2 and we would still have something in terms of k. So we want that k to persist because we want it to show up when we get to our 3rd step. Because our 2nd step says, hey, look at that limit as x approaches 2. And to prove that it exists, we have to look at it from the left and from the right. Now, I saw some of us doing this, but we weren't using the greatest notation. You need to use proper notation throughout this whole thing in order to get full points.
-2.
Sorry, -2. I keep doing that. -2. So we have that x plus 2 divided by an x squared minus 4. So that's going to be equal to, well, if I were to factor this, it would be an x plus 2 over x minus 2. -2 from, oh, this is from the left here. I have x plus 2 on the top, but on the bottom, x plus 2 and x minus 2, which these will cancel. Now we need to make sure we're carrying that limit. That's the most common notation mistake I've been seeing, is that limit is disappearing. How dare you. Limit as x approaches -2 here will be a1 over x minus 2. These canceled, left this way. Now when we plug in that -2, we're going to find a 1 over -4.
Oh, because we have to make sure you don't.
So I did all of this simplification here already. I don't have to repeat it. I can just skip to that, so I have x plus 2 over x squared minus 4 here. Well, we know that simplifies already. We don't need to show all our factoring steps here. 2 from the right. This is just going to be 1 over x minus 2. Forgot the parenthesis there. Which, when I do direct substitution, still gets what?
Same thing.
1 over negative 4. 2 minus, or negative 2 minus 2?
-4.
Negative 4. My minus signs keep melding with my arrows. So I've shown my limit exists because these two are equal. So now my third step says, hey, take all of those and show that they're equal to each other. So I know this needs to be equal to this. So I'm going to have a 2k plus 3 is equal to what? Negative 1/4. Can I solve for k now?
Mm-hmm.
Yeah. So we're going to add, no, subtract 3 from both sides. 2k is going to be equal to,
Negative 13 over 4.
yeah. Last thing, divide by 2. K will equal a negative 13 eighths.
It's negative 13 over 4.
And then when I divide by that 2, we'll get to the negative 13 over 8. That's almost off the page, sorry. So typically, because these will not just be made up off the top of their heads, it will have nicer numbers, but that wasn't terrible. It actually worked out better than I thought it would.
Miss Duncan.
Yeah.
Can I leave Ramon's price report with you? He was gone before he requested.
Yeah. Okay, so that's the end of that continuity bit. Let's go into some new material from the last week or two. Derivatives.
Yay.
Quick reminder, you need to know your laws for the limits. The limit as x approaches h of f of x plus h minus f of x
Oh, you can.
all over h. So, you need to recognize these rules. It is highly unlikely that they will ask you to do this by hand. You can either do it in your calculator, or you just need to recognize, hey, they're telling me to do a derivative. If I know f of x is x squared, what is my derivative? 2x. You don't have to go through that full process. Yeah.
Do you have wipes?
No.
I need, Thomas told me you have wipes.
I had wipes?
Yeah. Do you have any like tissue or anything like that?
I have paper towels in my desk.
Okay.
If you pull the middle out and look in the right drawer. So you have to pull it out to unlock it, and then look in the right-hand drawer. Look, like in the other drawer. So that unlocks it by opening it, and then you have to, this is all in the
I
video.
learned it
This
the
is
hard
fine.
way.
Thank you.
Yep.
Thank you.
Okay, our other rule is the one with our a value. So, oh wait, what am I saying? Ugh. The limit as x approaches a of f of x minus f of a all over x minus a. Once again, it's unlikely that you'll have to do these by hand. You should know how to. We've done a bunch with it. But the key thing is recognizing, like, oh, what the heck?
Oh yeah.
Oh, I was like, did he find those in my desk? Yeah.
The first equation is when they ask us for the equation of the derivative, right?
Yeah, so this one is better for if we want an equation. This one is if they give us a specific value to look at x to find a point. But yeah, remember that key thing is recognizing that just this is the definition of derivative. So then we could go through and apply our derivative rules to our function to find it. So unless it were to explicitly state, like, find this by using the limit definition, then you can be like, hey, I recognize that's a limit definition. I'm going to do my derivative rule. It is likely, though, that they may say, hey, you have to set this up, but then you may use a calculator as well. So that's why you need to be able to recognize these.
Oh wait, so we don't have to memorize them?
So have this memorized because you need to recognize it. But it's unlikely that you'll have to go through and evaluate this by hand.
Can you do the power rule on points too?
What does that mean?
So like, say they gave us, okay, we have a function f of x is equal to x squared. And they're saying, hey, evaluate the limit as x approaches 2 of x squared minus 4 over x minus 2. What you could do is if you didn't want to deal with the algebraic manipulation, you might be able to say, hey, I recognize that this is this derivative rule. It's f of x minus f of a all over x minus a.
I would not.
So I could find f prime of x using power rule. What I'm going to do is I take my power and I bring it down in the front, 2, and it's going to be x raised to a 2 minus 1 this time, or a 1.
2x.
2x. So now if they're saying, hey, we're evaluating that at 2, 2 times 2 gives me 4.
What just happened?
Is that the answer if you would have done it like that way?
If you had done it this way as well, yeah, because if you split this up, you had that limit as x approaches 2,
I get it.
x plus 2, x minus 2, over x minus 2. These will cancel. Limit as x approaches 2 of x plus 2 is still going to be what? 4.
That was amazing.
So we just need to know that that is happening so we can just do the power rule.
Yep, we just need to know that this is happening so we can apply one of our derivative rules, which in this case was that power.
What's the other derivative that you needed? Oh, you just factored. You just factored it. Right?
Yeah, I just factored, canceled out because it was a removable discontinuity. Okay.
Could you do one of the problems about like tangent lines on that?
You did that already.
We did that earlier. It's in the video if you want to watch it. Yeah.
Wait, you're recording right now?
Yeah.
YouTube.
Yep.
Hey, vlog.
Okay. Okay, so we're going to look at power rule. This was a really long video. I keep forgetting to pause it. Okay. So, key thing with our power rule is sometimes we have things that don't look like power rule that can be power rule. So like, we had some where it was like long fractions. We had x squareds minus x plus 3s all over x.
Yes, that.
I can do power rule. The key thing is manipulating it so that you can actually use it.
X squared over x.
Whenever you see big long fractions like this,
Negative.
break it into its parts. X squared over x. Each term is getting divided by x. So in this case, if I were to find my derivative, that this was y, dy dx in this case, that's our other derivative notation. That's going to be equal to, well, this simplifies to x.
All of it?
This simplifies to 1.
Negative 1.
Yeah, so minus 1. Plus a 3 times an x to the negative 1. So this last term here became that negative 1 here. When it's on the top here, it will stay on the top. If it were a number on the bottom, it would stay as a fraction. Okay, so if I'm doing my power rule here now, I assume my power here, if I can't see it, is 1. So I'm bringing a 1 in the front. So derivative is just going to be 1. What's the derivative of constant?
0.
0. And what's the derivative of an x to the negative 1?
Negative.
So that negative 1 comes in the front.
So negative 3x to the negative second.
So that negative 1 came into the front. I subtracted an additional 1 from here, so it became a negative 2. And we keep that 3 there for multiplication, or as we can probably see at this point, is a 1 minus 3x to the negative 2. If you want to simplify this even more, you could say that's a 3 over x squared. Okay, so the key thing is that manipulation point. So, yes.
So like, I remember whenever like we were in class, you would like put brackets on the dy over x.
That was when we had an actual function here. Or if it was in function notation, f of x. When it's just y, you can just leave it as dy dx.
Tomorrow's Friday.
Yeah. Is that a question? Okay. So,
Yes, miss.
any other questions on this, or do we just want to try some?
Sure.
Try some. Okay. So, we'll start out with a somewhat simple one.
Yeah, it's not
First one. It's not simple, but it's a good one.
I forgot what you do. You take out the 2. Can you do the little letter thingy?
What?
The little letter thingy in the square root. Remember you did the
The
little
rule?
letter thingy? Like the end. And the
Okay, so I have some questions about time.
Yeah.
Yeah.
This is technically a 2 if there's no number there. Is that what you're asking?
I can figure it. I'll figure it out.
Were you asking for the rule?
Yeah, the little.
Oh, okay.
So what are we looking for? What are we doing?
You're finding the
Derivative.
derivatives of each of these.
Oh,
I need to write anything.
So rewrite it, find your derivative. I'm gonna pause it, so if you are doing it at home.
oh, nice.
Oh,
Okay.
I gotta do the derivative.
So for question 1, 2 root
Shoot.
x cubed. We should write that as a 3/2. So then when I do my power rule, my exponent is going to drop down into the front, reduce it by 1.
Set up limit notation.
What is it? Oh, can it
To a 1/2. That's it, we're done. Leave it here. If you simplified, it would just look like a square root of x there. For 2, I give a hint already here, but 1/2 times 1 over x cubed. So when I finish simplifying that, 1/2 times x to the negative 3, or sorry, simplifying, manipulating, bring that negative 3 down into the front. We should have a negative 3/2 for our derivative then. X to the negative 4, because I'm subtracting 1 from here.
This is the wrong part of the question.
Watch your negatives. For 3, x minus 2 squared, we should just FOIL this out. X squared, not minus 2x, minus 4x plus 4. From there, we should end up with a 2x minus 4. So these are each of our derivatives, y prime.
How can I do this, but I can't do this? It's so fast.
Okay.
I don't get the
Now, make sure you study those product and quotient rules. LDR plus RDL and low D high minus high D low, all over low times low.
low.
Low. Okay.
Slow. Yeah.